Welcome students for the fourth part of the lesson Quadrilaterals. Now we are going to learn about parallelograms. What is a parallelogram? Observe this picture. You can see a quadrilateral with two opposite pairs of parallel sides, and the opposite sides are also equal. So in this parallelogram ABCD, AB is parallel as well as equal to its opposite side CD. Also, AD is parallel as well as equal to its opposite side BC. We have studied already to name opposite sides, adjacent sides, all that. So I'll be using these today when I explain. So I have listed here some of the basic features of a parallelogram. Okay, the first one is opposite sides equal. So in this figure, as I already said, AB, side AB is equal to side CD, side AD is equal to side BC. Opposite sides are parallel. So you can see one arrow mark, single arrow on AB and single arrow on CD. That means those two are parallel, mutually parallel. We say parallel to each other means mutually. Same way, AD is parallel to BC. So double arrow can be seen. You can see double arrow. So those two are parallel. Single arrow is parallel to single arrow side. Double arrow is parallel to double arrow side. So those are parallel to each other or mutually parallel. Third property is opposite angles equal. Which are the opposite angles in any quadrilateral we have studied? This is a quadrilateral, right? So opposite angles means angle B is opposite to angle D. You can see single loop, single loop. So those are equal. And angle A is equal to angle C. Double loop. I have marked using double loop. So those two are equal. Angle A is equal to angle C. They are opposite, right? Now, diagonals bisect each other. Bisect means we have already learnt this. Angle bisector cuts the angle into two equal parts. Diagonals bisect each other means one diagonal passes through the midpoint of another diagonal. So they intersect at the midpoint of each other. That means, which are the diagonals here? AC and BD. Correct? No, they are the diagonals. So midpoint of AC and midpoint of BD is the point of intersection of diagonals. They meet at each other's midpoint. Now, adjacent angles. What do you mean by adjacent angles? Angle A and angle B. Angle B and angle C. A pair of angles together, sitting together. Angle A and angle B. Angle B and angle C. Angle C and angle D. Angle D and angle A. So at a time I can say two angles which are sitting together, which are made at the continuous vertices. So they are supplementary. Supplementary means what? They add up to 180 degree. So angle A, you can see the double cut marking that when added to angle B will be 180 degree. And angle B and angle C when added it will be 180 degree because A is same as C, no? Now C plus D, angle C plus angle D also will be 180 degree because angle D and angle B are equal. That you should remember. each diagonal divides the parallelogram into two congruent triangles. Means if only one of the diagonal is suppose drawn, say AC is drawn, then the triangle ACD and triangle ACB, they are congruent, means they are equal in size and shape. So their areas will be equal. We have studied using SSS, ASA, any of these conditions we can prove that they are congruent. So they are congruent. Okay, remember that. Similarly, if I cut parallelogram using another diagonal BD, that time also they will be, the triangles will be formed triangles. CBD and ABD, they will be congruent. CBD and ABD, they will be congruent to each other. You have to remember this because there are, among parallelograms, there are some specific parallelograms. We have to learn that. So what is basic feature of parallelogram? Opposite sides equal and parallel. Opposite angles also will be equal. Okay. So you have to remember all these. Bisects, diagonals bisect, all that. Now naming the elements of the parallelogram, it is same as naming any quadrilaterals elements. We have studied, I have taught in the beginning how to name adjacent sides, how to name adjacent angles, how to name adjacent vertices. Similarly, how to name opposite sides, opposite vertices, all that, opposite angles. So when we name opposite sides, we are using two letters, AB and CD, BC and AD, like that. AB and CD, BC and AD. That is the way I name opposite sides. So remember this, you should learn for everything that is true, not just for quadrilateral. Quadrilateral is same as parallelogram. I'm not going to explain, just go through the page. AB and CD are opposite sides. I already told in the previous slide. AB and CD are opposite. Similarly, AD and BC are opposite. And the angles, opposite angles also, it is shown here. Whatever I didn't write in the previous slide, I explained for generally any quadrilateral. So you should know. Quadrilateral means parallelogram also is quadrilateral, no? Naming all these elements, it's easy. Already learned. I hope you know that. You have watched the video, right? Okay. Now, you can see now the features. Once again, I have drawn very clearly another parallelogram. It can be like this also, parallelogram. See, observe A, B, C, D. A, B and the opposite CD. See, it's equal in size. Shorter side, AB is equal to CD and AD is equal to BC. Opposite sides equal. Opposite sides are parallel. They never meet opposite sides. They will be always, even if extended, they will be going on and the distance between them will be always same. Like railway tracks, parallel edges. Opposite angles are equal. You can see double cut, angle A double cut is equal to angle C double cut. I have shown with the same kind of notation. It's marked the same way. So that means they are equal. Similarly, angle B, which is obtuse, ABC is obtuse, no? Same way, ADC is obtuse. They are equal. Opposites, they are opposite angles, they are equal. Diagonals bisect each other. Here I have shown it very clearly. You can see one cut, single cut on the diagonal BD. You can see single cuts. If you think that those diagonals are crossing at point O, then BO is DO. That's what it means. Bisect means. BO is DO. AO is CO. Remember, if you think that wherever the diagonals meet that X, that point is O, AO is CO, BO is DO. Remember, that is the meaning of diagonals bisect each other. What do you mean by adjacent angles supplementary? I told in the previous slide. Adjacent angles supplementary means angle A plus angle B is 180 degree. Here you can see angle B is obtuse, angle A is acute. So when you add, you will get it 180 degree. And angle C plus angle D also 180 degree. And angle B and angle C also 180 degree. Similarly, angle A and angle D also 180 degree. And the two congruent triangles also you can see here. I have named the triangles, congruent triangles. ABD is congruent to, that means along one diagonal if you cut the parallelogram, you will get two triangles. If you draw any parallelogram, you will come to know how to use set square and draw parallelogram. I will teach in the same video today. So if you draw like that and cut through the diagonal and then turn it or put it ulta upside down, then you will come to know that they are equal in area. The size and shape matches. So ABC and CDA. Another way also you can cut. But with one quadrilateral, you cannot cut two ways. Once you cut using one diagonal, it is over. It is cut into two triangles. One more copy of the same parallelogram if you have, you can cut using another diagonal wise also you can cut. The triangles will exactly match. They will be overlapping each other. Superimposed, we say. One kept above the other. That will be exactly matching in size and shape. Supplementary pairs of angles I have written angle A and angle B. So you can note down it. I have written it within the box. Because they are adjacent angles, I have named it angles A. Actually angle A plus angle B. Like that I should write the word angle. There is no place, so I have not written. Observe these angles. Single cut, single cut. Now I showed. That time it was confusing. That's why I kept only that double loop, double loop. Angle A and angle C I had kept. Now angle D and angle B also I marked. That they are equal. Both are obtuse if you see properly. They are equal in any parallelogram. Now, coming to types of parallelograms. We have three parallelograms. Three specific parallelogram which has some special features of its own. Any parallelogram can be square, it can be rectangle, it can be rhombus, or it can be other than this. Generally, any parallelogram need not be rhombus, need not be rectangle, need not be square. But these are three are called specific parallelograms. Okay, let us see what is specific about square. Square is a parallelogram. We all studied square before in lower classes. Square and rectangle is very familiar to us. So square is a parallelogram. Opposite sides are equal and opposite angles are equal. Is it only opposite angles equal or all the four angles equal? Yes, we have seen that a square has all the four angles equal. Each one is 90 degree. And it need not be only opposite angles. In a square, all the angles equal, all the sides equal, not just opposite sides. All the sides are equal. And diagonals equal. In any parallelogram, diagonals need not be equal. In the previous picture I showed, big parallelogram, tall one. Did you see the diagonals, were they equal? No, right? So, in this case, in square, diagonals are equal. Remember that. In any parallelogram, diagonals need not be equal, but in a square, diagonals are equal. All the sides, four sides are equal, two diagonals are equal. But the side is not equal to diagonal, remember. We have studied Pythagoras theorem. So in a square, there are two right angle triangles if a diagonal is drawn. Remember. So side is not equal to diagonal. Now, rectangle. Rectangle is another parallelogram with opposite sides equal and each angle 90 degree. Each angle is 90 degree. Opposite sides equal. Then diagonals are equal. See, diagonals are equal. That happens to be in a square also. So there are only two parallelograms where diagonals are equal. All of you know how to cut a square, isn't it? When any rough paper is given, we fold it like that. Kerchief is there, we fold it corner to corner. And we make different this kind of kerchief foldings, like origami kind of system. We used to make. I hope you all know that. So even square, there are something which is common in square and rectangle. What is that common? In a square also all angles 90 degree. In a rectangle also all angles 90 degree. In a square also diagonals equal. Rectangle also has diagonals equal. Remember. Next, for a rhombus, what is meant by rhombus? It's a diamond shape. A diamond is, mathematically we call it rhombus. In this, what is special? It's a parallelogram. Opposite sides are parallel. Now, it is not just opposite sides are parallel. All sides are equal, just like in a square. A rhombus has four sides equal. And if you just observe a rhombus, you will come to know that it is having two pairs of isosceles triangles. Above one isosceles triangle, below one isosceles triangle. If you consider only one diagonal drawn in a rhombus, you will get above one isosceles triangle, below another isosceles triangle, which is congruent. Now, if the rhombus is having only one vertical diagonal drawn, right side one isosceles triangle, left side one isosceles triangle, but they both are again congruent. Okay. So, you need to do this yourself. How will you create a rhombus? Take any rectangular paper. Okay, used paper, don't use empty sheets. We have to cut one tree if so many papers are used for paper folding. Now, any used rectangular paper, fold it once, exactly in the middle, vertically. Then, again you fold it horizontally. So, plus shape comes. One vertical line, one horizontal line. Now, join the four ends of the lines, midpoints, ends, using pencil. Draw a line and draw using pencil, cut it. So you will get a rhombus. How to draw a rhombus? Take a paper, vertically, top to bottom, one line, equal, mid line you draw. Like a margin in the middle. Then horizontal line you draw, same way. Okay, left to right, mid, at the mid center of the page. Where is the center of the page now? Where the diagonals meet, right? Now, ends of these diagonals you join using pencil. Cut it. You get that diamond shape. That is how rhombus is drawn. What do you see? Diagonals are mutually perpendicular. They are perpendicular to each other. 90-degree angle is made wherever diagonals meet, right? Plus the shape is obtained. Not a plus means plus only, not like a kite. Remember, kite has that one diagonal above, not in the midpoint. So, we say for a rhombus, diagonals are bisecting at 90 degrees. It is not just bisecting, they are perpendicular to each other. For a square also, if you do it, if you cut a square, you know how to cut a square, right? Using paper. Yes, sir. One flap you have to turn. One triangle, corner to corner, if you touch with equal sides, you will get a square. Using origami, I think you have learnt that. So in a square also, diagonals are making 90-degree angle, but not in a rectangle. Okay, in a rectangle, you will not get 90-degree angle. Yes. Now observe, see here, I have drawn more detailed pictures. Whatever I explained just now. First observe a square. What do you see? I have marked equal sides. Single cut, single cut, single cut, single cut means what? The sides of the square. Can you see? They are equal. I have marked all of them with single cut. That means they are equal. Then two diagonals are there, no? They are having 90-degree angle at the meeting point. So they are equal. Diagonals are equal. Not equal to side. Diagonals are equal. One diagonal is equal to another diagonal. 90-degree angle is understood. I didn't mark. L shape is formed at the corners, four corners. Coming to rectangle also, you can see opposite sides are equal. You can see the rectangle having the two opposite edges with single cut marking. Another pair of opposite edge with double cut marking. That means those two are equal. Same kind of notation. Marking means they are equal. Opposite sides single cut. Another opposite side double cut. That means they are equal. Parallel also, but I didn't mark it here because they are parallelograms. Opposite sides are parallel. One arrow, two arrows. Like that I should mark in the opposite side. Observe the diagonal vertically opposite angles. Opposite angles. When X shape is formed by two line segments or lines intersecting, we get something called vertically opposite angles. They are equal. So I have marked that. Single loop. Wherever diagonals meet, that angle is equal. Now observe rhombus. Rhombus has all the four sides equal. I said no, if you draw or if you fold a paper and cut, you will come to know. I said no, it is easy. Draw one plus shape. But just check whether that plus shape midpoint only is there. Then draw using scale. Sides are to be drawn. So PS, RS, RQ, PQ, all that to be drawn later after plus is drawn. Plus means diagonal. First diagonal to be drawn. Perpendicular diagonals. So surprisingly, you will get all the sides equal when you do like this. And in case you have such two rhombuses, first only you cut two rhombuses. Then using one diagonal you cut vertically and see whether the triangles are equal in size and shape. Triangle RQS and PQS, they will be equal in size. Similarly, if you have another Xerox or copy of this rhombus, cut along PR. Cut along PR and check whether PQR and PSR should be exactly matching in size and shape. They will come one above the other. Okay. Now, kite. Very familiar, I think. Kite, many of you know. Just like how you have drawn rhombus, same way, kite also can be drawn, but only change is, in this we have to change when we draw second diagonal. First diagonal, vertical one line you draw. As I said, fold the paper vertically, top to bottom, one line, midpoint. And now when you draw the second diagonal, slightly above you have to draw. Anywhere but above that red dotted line in the kite. Then join the sides. Now you observe that two adjacent sides are equal. Double cut I have marked. They are equal. And another isosceles triangle is there below. Tall one and long one. That single cut shows that they are equal. Those two sides are equal. Remember, trapezium is also not a parallelogram. So I have given that. A non-parallelogram. Non-parallelogram means it's not having any property of parallelogram. It's non-parallelogram. So kite and trapezium are not parallelograms. We have studied already what is a trapezium. Only one side, opposite sides parallel. But in any parallelogram, it is compulsory that two pairs of opposite sides are equal and parallel. So if you do this paper cutting yourself, you will understand. Otherwise, simply solving problems, you will not understand how to use the idea. I have listed the properties. Now, kite, I removed that picture. I have listed the properties of these. Okay. So, opposite sides are equal. And in which case opposite sides are equal? For square and rhombus, opposite sides are equal. Sorry, for square and rhombus, all sides are equal. Otherwise, opposite sides, however, equal. Why it is special? That's why I have written only for square and rhombus. Opposite sides are equal. And not just opposite sides, all the four sides are equal for square and rhombus. Opposite sides, basic feature of parallelogram. No, it has to be equal. In any parallelogram, opposite sides equal. But for square and rhombus, two pairs of opposite sides, just it is all the four sides equal. Each side is equal to another one. So can we say that for a square and a rhombus, not just opposite sides, adjacent sides also equal, right? Yes, we can call it adjacent sides also equal. Opposite sides, adjacent sides, anything, all sides equal. Opposite sides are parallel. That is true. Adjacent sides cannot be parallel, no? So for even a square and rhombus, opposite sides are parallel. Opposite angles are equal. For square and rectangle, special. All the four angles equal. Remember. As I already said, diagonals bisect each other. Diagonals are bisecting each other, means they will cut crisscross at their own midpoints. One passes through the midpoint of another. But remember, rhombus has diagonals not equal to each other. But the midpoint they will crisscross, but they are not equal to each other. You can see PR is short, QS is longer. But they pass through midpoints, remember, in this rhombus. But square and rectangle has diagonals equal. And the diagonals are perpendicular. They crisscross at 90 degrees in square and rhombus. But rectangle, you see, it's not 90 degree. It's vertically opposite angles. I said, no, it is not 90 degrees. It is more than that. Or it can be less than that. But it need not be 90 degree. It can be 90 degree. That is why square can be called as a rectangle. But a rectangle can never be called as a square. Remember. Adjacent angles supplementary. What do you mean by that? Adjacent angles. We have learned adjacent angles. Now in this rhombus, which are the adjacent angles? Angle P and angle Q are adjacent. They are supplementary. They add up to 180 degree. Similarly, angle Q and angle R are supplementary. 180 degree. Q plus R. R plus S also 180 degree. S plus P also 180 degree. Remember. Also, as we already discussed, I have written last in green, diagonal divides parallelogram into two congruent triangles. Now in this rhombus, if I consider one diagonal, PR, upper triangle and lower triangle. It matches. And if I cut along QS, another diagonal, right side triangle and left side triangle matches. Don't cut any rhombus into 4 parts. I just want you to try one diagonal at a time. I mean to say, have the rhombus, cut along one diagonal. You will get 2 triangles. They are congruent. And if the copy of the same is there, cut along another diagonal. You will get 2 triangles which are congruent. Remember, both are isosceles. One set of isosceles, another set of isosceles. Now, kite features. I have listed the kite features. You can observe 2 cut, adjacent sides equal. 1 cut, another adjacent side. So there are 2 such adjacent pairs. They are equal. Then only one pair of opposite angles equal. You can observe there I have marked one loop, opposite angles. Only one pair equal. Diagonals are not equal. You can see diagonals are not equal. That was not equal in rhombus also. But they are cutting each other at 90 degrees. Why did we use intersect at 90 degrees? I did not use bisect. Because that red diagonal, what is dotted line drawn, that is cut by another tall, longer diagonal at the midpoint. But that vertical line is not, another vertical diagonal is not cut by the other red diagonal in its midpoint. So one diagonal only passes through another diagonal's midpoint, whereas it is not true for both of them. Only one at a time. So we can say it is intersecting at right angles. We cannot say it is bisecting at right angles, like how we saw in square and rhombus. But in kite, it is intersecting at 90 degrees, not bisecting at 90 degrees. So these are the basic features of parallelograms and non-parallelograms. Among non-parallelograms, trapezium we have learnt already. Very well we have studied. But kite is like this. It's not parallelogram because it is not having opposite sides parallel. They are just having, kites are having adjacent sides equal. No parallel pair at all. In trapezium at least one pair is there. Here no opposite sides parallel, nothing. Parallel condition only is not there. So here congruent triangles. Can you find any congruent triangles? Yes, sir. Vertical diagonal drawn, right side triangle and left side triangle is congruent. But horizontal diagonal, red diagonal if drawn, it is no use. Upper triangle is smaller, lower triangle is taller. Isosceles triangle, but they are not congruent. So only 2 congruent triangles, right side one and left side one. Remember. Now, let us have some true or false questions. A rectangle is a parallelogram. Yes, we studied just now. It is true, right? Parallelogram is a rhombus. It is false because rhombus is a parallelogram. Every parallelogram is not a rhombus. So remember, in English, when we write the statement, we should be very careful. Parallelogram is a rhombus, but every rhombus is not a parallelogram. No. It is one of the parallelogram is rhombus. So it is false. A trapezium is a rectangle. What do you mean by that? A trapezium is a rectangle. Is it true? Did we study that? No. False, right? Yes, so it is false. A parallelogram is a trapezium. No, not at all, because parallelogram has 2 pairs of opposite sides equal and parallel, but a trapezium has only one pair of opposite sides parallel. Now we cannot say that parallelogram is a trapezium. Every trapezium is a parallelogram. Is it true? It's not. Trapezium has only one sides parallel. Therefore, it is not going to follow the rules of parallelogram. So it is false. Square is a parallelogram. Yes, of course, we studied it is true. All rectangles are square, right? No, it is false. But we can call all squares are rectangles. Remember that. But not rectangles are squares. Rectangles are not squares. Square is a rhombus. Yes, we can consider square as a rhombus because every feature, every nature of rhombus is there in square also. So it is true. Kite is a rhombus. No, kite is not a rhombus. Kite has not all four sides equal. Rhombus should be having four sides equal. Kite has no such. Moreover, rhombus is a parallelogram. Kite is not a parallelogram. Remember. Square is a trapezium. Is square a trapezium? No, false. Because trapezium has only one pair of opposite sides. Trapezium one pair only. It is not another should be non-parallel. That is why square has two pairs. Yes, here you can see the set squares. If you get any such double set square, maybe your brothers and yours, you can share and you can use both and form this parallelogram. You can see first one is a square. Okay, isosceles set square you have to use. Identical it should be, same brand. Camlin means both Camlin. You will not get same sized set square. Different box, geometry box has different. So another parallelogram using one way you can get like this. Actually you can use it in different ways. Try to do that. You will get different parallelograms. Same set square. Same two set squares if you use, you will get another type of parallelogram. Another way I have shown. Here 4 I used in one set square to form a rhombus. I used four different set squares but of identical size and shape. You can see how rectangle is formed using two set squares. Their rectangle is not using isosceles set square. It should be the other set square. Tall one is there. No, that one if you use two of them, you will get rectangle. So I will end with the lesson today here. You should learn the properties very well. Then we will be able to solve problems on that. Again, when I take up problems, I will help you understand the basic features once again. But you should know using these pictures. When you cut it yourself, you will come to know how to make quadrilaterals, especially parallelograms. Okay, students, all the best.